Hello guys, it's Eric again here, and today I have with me Daniel and Juan, both from the Quantum Core team. And we're gonna do a quick challenge here, which is let's um, let's create a 2D car physics, top-down car physics, a bit like Death Rally or things like that. We're gonna base this on some previous work we've done on 3D cars and try to very quickly come up with something that will work nicely. So what we have here is we have so guys, please say hello.
Hey,
Hello, everyone. Mhm.
Okay, so we just got latest Quantum SDK. It's a clean project. There's nothing implemented here yet, and we'll add things as we need, but we'll actually start from Unity. So let's open our whatever latest Unity, stable Unity we have here, and start creating our entity prototypes from there, and not really start coding. So we'll go for our 2D car project here. Oh no, let's start with newest Unity version. Actually, we could use that one, but that's nice. So let's use the latest one we have. And Juan, do you want to comment on? You can comment a bit on on your what you want to have for the car, so we can fine tune it for that.
yes, I'm doing a top-down 2D game. It's a battle royale game, and the idea is that we need some vehicles. It doesn't need to be realistic or anything like that. It just needs to be easy to control and fun. And yeah, that's it. It's not really needed some realistic power physics.
Cool. So yep. So while we wait for Unity to load here, although we don't need to, let's start organizing some of the some stuff here on the project. So uh, I will add a full oh no, not yet a file. I'll add a folder here for cast 2D. I know one is gonna import this later on however he wants, but let's call this cast.qtn for a quantum file. And we're gonna create some components for for the car. And one
You
notable
should
one is
increase
going to
the
be
font size.
steering. Yes, we should always increase font size. And another thing I'm going to also go ahead and do is I'm going to set up the input for this because I want to have a very basic input system in that we make use of the cheapest input types of them all in Quantum. I'll call gas, I'll call brake, or reverse. So we can call it reverse. I'll call left and right. Ideally, we should, depending on the game, we would like to have analog kind of left right, so you can have a more gradient for the controls. But that's not the goal for now. So let's start here and set up the project. So we'll start with our default quantum game scene, and because we're gonna work for this as a 2D game, let's see how. Do you guys remember how we can? Uh, let's see the gizmo. Yeah, here we have. So this is our. So the green one is normally the one for nav mesh, and the blue one is normally the one for physics. What we'll do here is we'll start creating our a quantum entity. So we don't want static colliders yet, although we'll add a few soon. Let's create a quad entity here. Later on, I'll make this guy a 3D view at some point, but for now, what I'm interested in is I wanna define what this entity prototype will be like. So I also want to do this already, so don't forget later. So this guy is gonna have a physics collider. It's not gonna be a trigger, and I wanna make it. So let's make this guy have one in this direction as well. So That means we'll make this 2. No, 1 does not work for the mesh renderer.
See?
Oh, it's Z, yes,
See,
because
yeah.
this is top down. Yeah, so let's make the car has this general shape here for now, and um, the whole thing is this car is going to be a physics body. I'll just use everything default here for now, and that's it. Um, we'll also do so. If we press play here, this guy is going to be falling because there's 2D gravity. So let's disable that. And so we don't want to have gravity at all because this is going to be a top-down 2D physics thing. Everything else I'm going to let as default. So let's go now do some coding. So for steering, as I said, we're going to be referencing an existing project, and I just need to check again a bit about the old one that we did. So we'll set some slip force position. We don't need this. We'll have the settings. We don't need. Yeah, that's enough here. So we'll copy a few things from one project to the other, and I will explain what they are as we start coding here. So this, and because we'll copy and paste some code to give us some leverage here. Any comment, guys?
So far, so good.
So dynamic grip, wheel angle. We'll need these. Yes. So these are nice. So these things will control how you can actually turn the car. And we're going to be making use of a asset, a quantum asset for this, that I'll also copy the whole class. So let's create it already. So I'll add a class. We'll call it, it's called steering settings. Just call it like this. But I'll copy the contents because I already have it. This, I can copy it as it is here. New one. And let's see if I have anything here that is, everything is 1D here, so it's good as it is. So this should be our steering component. Let's also make another component. I'm sure Juan has this in his own.
Yeah.
But we'll add it here for now. And I'll create another one component for, do I have it on the old one? I think we do have another one, which is called vehicle. Yeah, in this case, I have damping engine force and I have engine force. That's all we need. Because everything else is about, it's about 3D that we don't need. So yeah, let's call this engine force and braking force. That should be enough for us. So I don't need to, in this case, I don't need to copy and paste. Let's create it. So how should we call this? Let's call it drive train, something like that. Although we're not gonna have gears for now, anything like that. But let's call this engine force, brake force. So we have some values to work with. This should let us compile it, although nothing is gonna work. Okay, yeah. Component cannot have the same property with the same name as the component name. So now let's create a system for this. We'll call it cars system. And this guy is in the right namespace. it will be so before anything, let's create a public struct filter. We always do like this now. It's a nice pattern. So, then we put all the components we're interested in here as pointers. So it's a 2D game. Transform physics body 2D pointer. Let's call it body.
You missed the body thing because it's body.
Thank you. It's gonna be faster. And then we'll use our define components as well.
Steering.
So
Yeah.
steering and one for player. I should call it player. I should call it something else. Should not call it player. So, and the last one is the drivetrain.
I used to call it player link or something.
Yeah. Anyway, it's not. So with this here, we can make this guy inherit system main thread filter with the filter struct. Does it? No, does it work with that? No, it's. I
I
think.
think the struct needs to be declared outside of the class. No?
No, it's class system dot filter. That's
Yeah.
the type, and then we can implement this, and here it is, our updater for our entity. So now let's copy and paste some code, because we have almost everything ready here. So in our vehicle system, one thing we have is I cache some stuff, and most importantly, on our update method here, get input. We don't need grounded, we don't need wake up for now, we don't need sleeping, we don't need raycasting, and the only thing we need is to make the car go forward or reverse. So, and we'll do this by adding forces. So let's do this on the new one. Oh damn. It's good that I made this mistake, because I will just do it by hand. So input will be f.get player input from our filter dot player owner. Oops. That's all we need for input. So let's copy just the right method here, which is these two things here. Let's see how this translates to the new code. So if we have gas, we'll just body add force. We won't need add position. This is something that we only needed for the 3D one if we wanted to apply it a little bit down. So we use forward from the car and see how it goes. How is this called? So this is called drivetrain now. And then we have engine force. And because there is no position, this is just a force. And if it's reverse, we apply drivetrain and we apply the reverse. Brake force. Did I call it brake force? I thought I should have called it reverse. Oh yeah. Oh. Yeah. This should be the reverse force, but it's interesting because we should do this a little bit different here. So if we're moving forward with the car and you press reverse, it should brake. So it should apply a certain force that's kind of strong. But if your speed is actually 0 or going reverse, the force should not be the same. It should be a smaller force, because you should not be able to drive backwards with the same speed. But we'll see. We can upgrade the codes to do that. That's enough for now to make the car go forward and back. But let's already go ahead. This is not enough. Let's go ahead and also add something like the steering, because this is the part I'm most interested in, because it will be the thing that will better translate, I think. So in this case, I'm using up-down 3D things that we won't need. So we'll just delete a lot of code. You guys, you see. So first thing, we don't need up, but we might need rotation. Let's see. We don't need grounded states. But this is an interesting thing. So we need to check if we're going forward or not. So it's just translating from 3D to 2D. So we project the velocity over the forward vector of the object, of the entity in 2D, and that's what we have. And steering input, maybe I should go ahead and use the steering as I did on the other project for now. Yeah, I'm using the right one, sorry guys. So I should do this here. I'll do it like this, so we don't have to translate the code. Juan, you know that you're gonna use a byte in the end for this, and you move left or right as yeah, to make the negative and positive values. But okay, so we have a steering value that will be something that we clamp between -1 and +1. Then we have we check the angle we have, and we reverse. If we're going in reverse, we should make the car turn differently. So that's how, with this fake arcade systems, that's how this works. So we also did this on the 3D one. So this again is just, we're projecting here. Oh, so this time, so current rotation, oh, this is easier, because in this case in 2D, we don't need any projection for that. So it's directly the angular velocity.
It's always related to Z.
Yeah, it's always related to Z. Yeah, so that's or Y in this case. So
Oh,
that's,
yeah.
so what we do is, so this is the amount of rotation that we're gonna add. Yes. So we're gonna integrate more angular velocity to the object based on this. And max rotation, there is no grounded. So it will always be this, which is the steering factor. Yeah, this is an interesting thing, because we're gonna draw a curve here. So when the car is stopped, is zero velocity, you are not able to rotate it, because notice that this is just applying a rotational velocity to the entity itself. It's not applying really steering angles to wheels that do slip computations. This is just a very simple thing that rotates the whole body. And we don't want it to be kind of like super fake, in that when you are stopped, you can rotate the whole car. So this is not going to work, because we're going to make the curve be proportional to the speed. And then and we also make sure that the car will drift a little bit, that when you're at higher speed after some factor, you start actually decreasing the amount of grip you have. So this is the steering factor, by how much you can really turn at speed. Yeah, something like that. So this is a very common curve for for slip, but
Yeah.
we'll apply it with this completely fake model, and it will look nice. That's the whole point. So so max rotation, good. Then we don't need this, so we just do angular velocity plus rotation. That's already using delta time, so it's already integrating correctly. And last part, we apply drag, because we're gonna do. We also have drag from the actual physics engine, but we're gonna probably disable that drag and use this one here that we can control differently. So I don't remember exactly why I did this, but that's it. And then yes, this is interesting. So this is the whole grip model. So we project how much of the speed is now over this making the car go sideways, because you just rotated the car slightly, but we didn't change the velocity of the car. We didn't apply any force to the car. So if you were going forward and you make the car kind of like turn the whole body to the left, to the right, for example, it means that you're kind of starting to go a bit sideways. So we compute here how much we're going sideways. And then what we do is we compute grip here, and we apply a force to make the car go in. We apply an opposite force to make the car stop slipping, and this force is going to be applied projected to the sideways vector on the car. So I'm just copying the 3D version here, simplifying it for 2D, and it should already work. And that's the whole code. We should have something functional already. There's one thing missing. I always forget about this.
Mhm.
So let's add our system here. So what we'll add here is new car system. Done. Let's build again. Let's see if we have a functional controlling car. Now, we need to add a few entities for this thing. And just like with the ball sphere physics thing and on something being complained here. I think I have a compilation error somewhere. Do you remember this one, Juan or Daniel?
Not really.
Seems new to me.
I'm trying to remember why I'm missing this. Yeah, I need to. I failed to understand why this is a thing here. It's not complaining here. Not here. Is it still complaining here? Okay, now it's complaining. Why are you complaining here? Here are them.
Hmm.
It was not complaining when you first opened the project, right?
No.
But you
Oh,
did
I know.
it.
I've done this error before. You. So how do you call it then? It's player link.
Clear link.
Yeah,
Oh,
that was why.
so
So
clash of names.
yeah, name clashing. So player link. Let's make this thing be a player link, and it will work. Yes, build. So we will not complain anymore. Yeah, nothing to do with. Do we have it? Yes. Okay. So now let's add the things we need here. So this guy. So this guy needs the steering. This guy needs drivetrain. This guy needs player link. Let's fill in some data here. So we want to test this. So let's set the player to be first player. So we have something. Let's add some values here so we can do something. I'm pretty sure this is in angular, in angles, in degrees per second. So I'll keep something reasonable here. Um, let's add some torque, some rotation drag that I can think about. And grip multiplier, I think we need something interesting here. Yeah, I'm gonna reset the angular drag here. We want to have some forward drag because the car is gonna be stopping automatically. Or we can compute manually as well, just like we did for the other one. But this should be enough. So we have something here, but our input script is not gonna do anything. So we need to set some data here in our input variables. So let me think here how we should do. So first, var x equals dot get axis. Let's get the horizontal axis. And so I dot steering equals x dot 2fp. So this converts from float to fixed point, and that's it. And we need something for gas. So one thing we can do is we can check. Um, let's do vertical. Then we can do z, and if z is larger than 1, we do I dot gas equals true. Are you guys still with me?
Yep.
I'm here.
If z is smaller than 1, then oh, that's 0. Smaller and bigger than 0, then we press on the brakes. This should be actually a separate button for brake. This is actually the reverse. We're simplifying it.
Hmm?
We should have a separate button for handbrake. But this should be enough here for now. So we have functional controls. Let's see if we can make this guy move now. Did I miss something?
I don't think so.
Yeah, but it's not working. Oh, something wrong here.
Update
Oh, yeah, of
steering.
course. We need our steering asset. We
Mhm.
need our steering curve for, so steering settings. So steering settings, I'll call it like this for now. So we need to draw a curve here. Let's do something like this, but we'll convert it to what we actually want. Something like, how can I, what is the value here? Oh yeah, 0, 0. Oh, that's minus 0. Oh, that's 0, 5. Yeah, that's already 0, 5. Yeah, so we want something like 0, 7 or 0, 8 is normally common. We'll add a few keyframes. Let's add a key here. And another one. How many do we need, Daniel?
I guess two is fine.
So, you mean
Depends on,
something like this? Yeah.
yeah. This is one, right?
Yeah.
Yeah.
Yeah, this is one. So let's get it on the range we need. So this is the range we need. So this is going to be evaluated here. Yeah, I think something like this should already give us an interesting value. Is it in
You
0.2?
yeah,
Let's
you might
move
want
this a
to
bit.
go
Yeah, move it
to
a
the
bit
right,
to the
otherwise you will
right.
start too soon.
Yeah, something like this should be fine. Maybe I want to do this a little bit like this. Yeah.
So it's harder to turn when you're stopped, right? Or in
Yes.
very low
Yeah. Yeah.
velocities.
We'll think about it. So this is it, and this speed divider is important because it gives us the max speed. So what is the max speed where we have this clamped value here? So let's say this is at 20 meters per second. We'll experiment with it. So let's see. This is for the steering. See if we don't have any issues. We still have an issue. Oh, yeah, because I did that, but I didn't link it.
Hmm.
What is the point? So now we should be able to link it here. Clear everything. Should have a clean run now. Okay, no errors. And the car can turn. It's just that the axes are wrong. So let's fix this. So, oh damn. So what is happening here, Daniel? What is the axis? I'm using X as forward. Yeah, that's normally what is the convention. So right is forward on 2D because of these platform games. We can just fix it to be that. It's fine. So where's our collider here? Let's invert the collider here. So 0. Oh, this is going to be a 1 and this is going to be 0.5. Okay. And this should be how we see the car. I don't care about this right side camera. Let's see. Forward makes the car goes forward. Oh, the the curve is inverted somehow. Why? Reverse is working perfectly. Yeah. Why do they have to invert it here? Anyway, there are several ways to fix this. I can just do with data here. I can just make this -2. Then it will be fixed. I don't remember why
Maybe
it
it's the
was inverted.
maybe it's the direction you are projecting the velocity to
Oh
compute
yeah,
this
it's still wrong.
sideways.
Hmm?
Maybe it's the direction you are projecting the velocity to compute the sideways slip.
Yeah, let's take a look at the code. It was working in 3D. So update steering, we have, oh, yeah, so we have, okay, so this is computing correctly because it's transformed. Aha, I know. You know why? It's because this is them 2D.
Yeah.
So you see,
Mm-hmm.
I think we should fix this to make up be forward.
Mm-hmm.
To make this up be forward, we will use up instead of forward everywhere because this forward thing actually is right in 2D. So we make up down. So this instead of forward is up. So we can correctly use left here. Is there anywhere else we use up or down? No. I think that was it. And we'll have
Yeah.
to fix the car body again. Because now it will be correct. Okay. Okay, but the point is the physics thing is already working. And one, because we also define how much lateral grip you have, you can use that value to create a roll in the car body, just like we did for the other sample that you can have access to. So you can make it visually look like it's tilting, rolling the car because of the grip. And that would be, but that would be
Mhm.
just completely visual. So let's fix again the car proportions to be the right way. So then 0.5 here and 1 here. That's it. So yes, so forward will be Z, um, which is up into the. Okay. Oh, but it's still inverted. Interesting. I'll fix for good here that I'm using. So let's reason about this here. So I'm rotating here, and maybe this is supposed to be right then. Oh no, I know. It's not. It's not that. That's fine. It's negative here. I'll remove it and should be. I don't remember why in 3D I had to do it like this. I think it's because I was computing the relative velocity based on an axis, and the value of the axis was making it be negative, or I don't remember. The math slipped from my mind right now.
Yeah,
Uh,
just changing in the space makes it harder because sometimes the forward in 3D makes sense, but in 2D, as it is the right one, it changes the perspective.
okay, let's press play here. I thought it was playing already. Okay, now it's playing. It's still inverted, Daniel. And see what it's doing? There's something still off on the projections, so we missed still something. So
Yeah,
this is
so you
purely
are adding
left.
this, right?
Yes.
With just rotation torque, steering input.
I
What is the
think I
steering
think
input?
this has to be negative. I think I should subtract it then. I'm sorry guys, the math here is a mess right now. But I noticed that the grip was being compounded. So this was actually correct. And what I was doing wrong is that the car was rotating to the inverted direction, and this is okay because this is based on the velocity that I need to know if I'm going forward or not. So maybe so up and velocity. No, that's correct. Okay, I'll just invert here because I noticed that it was inverted as well on the when going reverse. Juan, are you still there?
Yeah,
You said that you would leave.
yeah. In 5 minutes,
Okay.
I'll go buy lunch.
I think you'll have time to see it working. Yes, it's working now.
Nice.
Yeah, so it's a bit. Yeah, first.
Slippery.
Yeah, first thing is I need to remove these gizmos because they're a bit. They make. Yeah, it's not. It's. I think it's just. It's rotating too much. So first, I think the max rotation speed is too much, and the
I guess you
engine
can disable the
force.
quantum starts to make it cleaner
Yeah, we
to
can
see.
make it for. How do I? There is a way to start disabled, and we can also make the camera and put some floor here so we see better. Yeah, it's now it's just calibration, right? So
Hmm.
So you do have a value on the asset for the drag, on the angular velocity, or something like that.
yeah, it's all in here. So I think this rotation speed is too much. The rotation torque was kind of fine, and I also want to make sure the input settings here on Unity itself. So we don't want this guy. We want this guy to be very snappy. So as soon as you press something, it immediately uses that as input. There will be no delay on moving left or right in terms of. So let's add a little bit more force. You know that the thing here is that the more force you have, the faster you go because the what is limiting you is drag.
Hmm.
So as you add more force, your car is gonna go faster. Okay, it's better now. Yeah, now it already behaves better. Yeah, this is nice.
I can use it already
Yes, you can.
in the
It's
test.
already nice. Yeah, I know it's when we have gizmos, it's super bad. So yeah, this already feels cool to control. Done.
Nice.
Yeah, now it's just visuals and calibrations. So you see that it looks like you're drifting. I know, yeah, there is no reference with. We should have a floor or something, but you like it. That's it.
Yeah, but the
Yeah,
perspective in the camera helps to
Hmm.
perceive the
Yeah,
sleeping.
and if you have, it's important to have texture in the background so it looks nice. So if you need
Hmm.
to go one, you can go, but I'll just add a few things to the so we can see something here. So let's add a quad. A unit. We
yeah.
don't.
So I'll
We
leave it and I'll back later. Bye bye.
Yeah, yeah. Bye.
See you.
So Daniel, let's add a quad here. Can I do a quad? Uh-huh. And I'm gonna rotate this guy 90 degrees. And I'm gonna make this guy bigger. And should I create a material? Are you still on?
Yeah, here.
Easiest way. Checkered pattern. Do we have a texture like that? Nah, there's oh yeah, here's default checkered. This should be nice. So I'll add this checkered pattern. Oh, it didn't work. So to the quad, yes. Now let's tile it a lot. So that was 100. So let's do 16. 16. That's enough. No, more. 32. 32. That should be nice. Where's our car? So we'll do something with the car here. So we'll add a 3D object to it.
Hmm.
We'll add a cube inside it. We'll make this guy. Is it right? Yeah. and I'll scale it in a way that it will be visible here. Yeah, and this 0.5. Is it like right on top? Yeah, oh,
Point
that's
20.
nice. It's slightly
Oh
hovering.
yeah.
That's nice. And we don't need it to render anymore. So that's
Hmm.
cool. So let's see how this thing plays now. Yeah, this already looks much better, right?
Yeah.
See, I would not change a thing here. And as we are almost stopping, we cannot. We can. I am trying to turn. The car does not turn. That's how I wanted it to feel. So yeah, it's not perfect,
How
but
how does it feel if you go like really fast forward and then try and turn like
let me see. That's how it feels. It feels very good.
nice responsive? Yeah.
Yeah, yeah. I think we need a little bit more rotation drag so the
Hmm.
car straightens faster, so it doesn't slide as much like this. And that's super easy. We have full control of that here. So where is our steering component? We have just one. Let's add three rotational drag. So that could be what I was missing. So yeah, it's straightening up much faster now. Yeah, it feels so nice. Yeah, anyway, the camera make the car tilt. So we have some minutes. Let's do the car tilt here. Car tilt is cool. So the car tilt script, we can do it completely on the Unity side. Car roll, let's call it roll. Roll. That will be the name of the script. Should I copy it from the other one? I think so.
Save some time.
Yeah, let's. I get because there's some code to get access to the entity. Blah blah blah. That's easier to get from what we already have, so we don't have to do it twice. So it just a few minutes here, a few seconds actually. So scripts, car follow car tilt. Let's open it here. Okay, so this is the script. So let's just take a look at here. So we'll need tilt lerp, tilt multiplier, max tilt angle. We don't need pitch. Oh, pitch is nice as well. Yes. You know what? Let's just get everything. Let's just get everything and we'll see if it works. Well, we'll have to fix the quantum part to so it fits the. We'll have to fix the quantum part to fix the right components, right? So see this.
Hmm.
This is not a vehicle, a sphere. So what do we need? We need the steering. This steering in quantum. This is the one we need. And oh no, we need steering, and we need also the player
Player.
link. Player link. So player link is where we get this guy from, and it's called owner. We need this thing to be unsafe. So we have the grip. There is no grounded in 2D. So, but we don't have grip if the car is not turning. So if you, well, technically, if you're still sleeping, there should be a tilt. But I think this felt nice that if you're not turning, the car is not gonna roll. It should not be called tilt,
Hmm.
but should be called roll. But anyway, um, and that's it. That's it. I think, yeah, the tilt is this. I don't need the pitch. Oh, we do. Forgot. So, are we doing something with the pitch? Yes. Yes, if we accelerate or reverse, we do some pitch. So, what are the default values? So we do have default values. That's nice. So, we just need the car body. Nice. That should be it. So what we do now is we drag this script to the entity view because the entity view is the one that will give access to the entity. But this cube will be the car body. And as we check the script here, we need to drag the car body here. I hope the X's are all correct. We fix if
What
needed.
is what is this tilt speed?
Oh, we need some tilt lerp speed, yes. Um, because we don't apply the full tilt immediately, the
Mm-hmm.
car rolls like slowly. But it
Mm-hmm.
needs to be. I think 8 is better, but we'll see. Now behold. The acceleration is nice.
It's
The pitch, see, can you see that?
mm-hmm.
The pitch is working quite nicely. So we accelerate, the car does that. Oh, damn. The
Now I can see
yeah,
one.
like this is better,
Yeah,
maybe.
nice.
Yeah, this and this. So you see, this is the pitch
Mm-hmm.
for accelerating and reversing. So the tilt is not enough. We need more tilt. Oh, the tilt
And
is
it's
inverted.
tilting inside. Yeah,
It's
it's inverting.
inverted. So I remember that. I need to do a negative value on the tilt multiplier. And the max tilt angle is 15 degrees. Maybe that's even too much, but it depends on how arcadey, how toony you want this to look. Let's see if it's tilting enough. Yeah, now it's nice. See? That's what we
Yeah,
wanted to have. Cool. Yeah,
super
lerp
nice.
4 is not nice. We need better lerping. We need something like 8. The pitch is too much. I'll do something like 6. And
I
and
thought
this is
that
going
the
to be
pitch was
proportional.
nice.
You thought? I think it was too
Yeah,
much.
but
Yeah, this is enough.
maybe
See?
it's too
Yeah, now
much. Yeah.
yeah, the roll is nice now. Yeah, now you really feel like you're driving this thing, and
Mm-hmm.
you just add wheels and the wheels don't need to change position. They just need to rotate, and you make the front wheels rotate with the steering angle that you have
Mm-hmm.
set on the steering component. And that's what it is. Okay, cool. Car physics ported to 2D. Thanks, guys.
Nice. And it took us 1 hour,
Yes,
less
one
than an
hour,
hour.
everything, including the visuals. Yep. See you.
Nice. See you.
Yep. Ciao.
Ciao.